Hi guys, in this tutorial I'm going to show you how to build a bridge, a truss bridge. So we can build this truss bridge and then simulate some loads on top. So just follow my lead and do this step by step. So the first thing, I'm going to create the project. Truss bridge. Then I'm going to select, I'm going to create the sketch and select this plane. So I'm going to create some construction lines. So I'm going to create first some construction lines. So I need to activate construction in here. And the span of the bridge I'm going to build is going to be 600 millimeters. So I'm going to do half of the bridge. So it would be 300 millimeters, and then I can mirror the other part. So in here, if we go back in here again, line, and then we activate the lines, or you can just type the letter L and you activate the line. So let's do another reference line just in the middle, maybe 50 mils high. No, set 500 mils high, just for reference. Then the first thing I'm going to construct are the triangles for the truss bridge. So let's do some triangles again with lines, and the length of the members, they're going to be 200 mils, and the angle is going to be 135. So it's okay, 135 is okay, because we want 60 degrees angles. Sorry, it's 120 degrees, because we want 60 degrees angles on each triangle. Now we do another one from here to here. So 200. And the angle okay. So now we can get rid of these measurements that we don't really need it. So you can see we have 300 millimeters bridge, but it's going a little farther. So this is the gap in here. This fit in the gap finish. So over here will be the resting points. So I want to draw some beans on the top. Here, and beans from here to here. Alright, okay, so if you reach this step, we can duplicate now. We can duplicate now what we draw with the mirror function. And then we select this as a reference. Alright. So now we have our full span truss bridge, 600 more than 600 millimeters in the span. Now we are going to deactivate the construction line, and we are going to build the beams, the real beams. So we are going to use the offset tool. So can you see we already create one side of the beams, 3 millimeter stick, just for the test, and then we are going to create the other side of the beam. Alright, offset. So in this case it's going to be negative, -3. Alright, so now we have the beams all around the bridge. Now let's create the beams inside the diagonal members. So offset tool, trim mirrors, and then we select again. Be sure you select the construction line, otherwise you get a trouble in there. Right. So now after you do this, we have to be sure on the corners, on each corner we got actually the nice shape, and we can get rid of the extra bits that we don't need with the scissors. Oh, can you get rid of that? Alright. Alright, so once you trim all the points and you are sure everything is fine, we can finish the sketch, and then we extrude the bridge. So I'm going to extrude at 100 millimeter stick. Alright. Okay, so now I want to put some cross beams in the middle of the bridge, so it will provide more stability to the bridge. So what I want to do is to visualize the origin and create a sketch in the middle. Now we visualize again the body, and we are going to create some construction lines because they are cross beams, so basically beams a line from here to here. Then we use the offset tool to offset 3, 3 and -3. Then you can trim the extra lines again. Alright, so you do the same in each corner. Alright, so once you finish with the sketching the cross beams, you can extrude it. So finish with the sketch, extrude, so you select the X that you just did, and you are going to say to select symmetric and join. So we are going to go all the way until the end. Yep, should be okay like that. Okay, now we got the cross beams, but the problem is that we have a constant cross beams all the way. So it's not very efficient in this way. So we are going to just hollow the structure a little bit more. So let's go to the bottom. Then we are going to create a sketch on this side. So we are going to create some rectangles to hollow the structure. So if you want to be very precise with the measurements, you can select the thickness of the beams, the cross beams that you want. For example, if you wanted like 6 mil, so you always separate here the rectangles 6 mils one from another. If you want to be very precise. Okay, when you finish with the rectangles, we can finish the sketch, and then we are going to extrude this. All the way through. Alright, so we got our beautiful truss bridge with cross beams. Can you see my cross beam in here is very weak, it's going to be very weak, so you can go back on your drawing and fix it. Alright. So I'm going to the next step. I'm going to test the strength of the bridge. So we are going to first be sure you save. So now we are going to here to the from design. We are going to switch from design to simulation. So static stress. And the first thing I want to do is to create a mesh. Okay, once the mesh is created, so we are going to select the material. Study material is going to be NDF. And then we can select the constraints, so basically the resting points. The resting points of the bridge. So we can select this point and this edge and this edge as the okay. So the next thing we do is to place the load. So basically we want to place the load on the top face. See here. And I want to put 570 newtons. Alright, on the top of the load. Okay. Now let's pre-check that everything is good to go for the simulation. Okay, and then we can solve. So we can select locally, so it's going to be faster, and solve. Alright, once the simulation is complete, you can see the results of the simulation. So actually my bridge is quite weak for the load I put. You can see here actual minimum safety factor 0.06. So basically it didn't meet the specifications. And here you can select the recommendations. Basically you need to strengthen the design in the weakest areas. You can see where are the weakest areas. So this is important data that you can take into consideration. And you can as well visualize the stress, visualize the displacement, the reaction force, strain, and here you can read the scale. So there was a lot of displacement in the middle because obviously the load is there. So basically your job is to reinforce the bridge until a minimum of a safety factor of 2 can be reached, but also don't over-engineer the bridge, because if the bridge is supposed to have a safety factor of 2 and your bridge is too strong and you use too much materials on that means that you are wasting resources. So maybe your safety factor is above 5, it's going to be a waste of materials and design. So you have to be into a safety factor of 2, maximum 4. Right.